I don't watch Fox News. Okay. Okay. All right. Mean, median, mode. Here we go. What we're looking for next is we're looking at extracting information. So we're in that circle where we're extracting info. And what we want to find is we want to find a representative value. Okay? Or we want to find what's most often called a measure of center. A single value to represent all the data. We want to find a representative value. We want to take all this observations from the sample, all this stuff we've got, and we want to somehow put it into a single number that will then represent all the data. Okay, and then that's the number we're going to use for all of our analysis. Now, there are lots of ways to find a representative value or a typical value. Okay, there's a lot of ways to do that. We're going to look at 4 of them. 3 you're responsible for. But I look at the 4th one because there's a number that's really important to some of you that's calculated that way. So we're going to look at 4 different ways to find a summary value. The first one, the most common one, is of course the mean. Or the average. And we're going to use an X with a bar over the top of it to stand for that. So every time you see an X with a bar over it, like the X bar ranch, that's the mean or the average. How do you find the mean? You add them all up and divide by the number of them, right? Does everybody agree? That's how you do an average. You add them all up, divide by the number of them. Okay, here's what you just said. That's a little X with an I by it. Okay. That's what you just said in math language. You just said the mean, okay? You just said the mean is found by this big guy. This big E means to sum. Okay? So step 1, sum the individual observations. So that's why this X has an I by it. It's standing for all the individual observations. So it's observation 1, 2, 3, 4, 5, however many there are. So we're going to sum them all up. That's what this top part means. Sum up the individual observations. What does this line mean? Divide. So step 2 is divide the sum found in step 1 by n, or the number of observations. Okay? Now, you already know how to do that, right? You've probably done that many times in your life. But if I would have written this formula up, some of you would have gone, I don't know how to do that. Yes, you do, okay? My point is, and the reason we always ease into math this way is you know how to do this stuff, okay? You just don't know the language, the math language. You know that you're supposed to add them all up and divide by the number of them. You know what you're supposed to do, okay? Right? And it's really simple to do, right? But it looks really hard. Every time we have a formula, and when we get ready to do our next time we meet, we'll have a really big, ugly formula. But every time we have a formula, this is what I'll do. I'll put the formula up, and I'll tell you what everything means. This is the number of observations, okay? And I'll define what each one of these symbols means. And then I'll write out in steps, step by step, how you do it, okay? Okay? Now, the reason mathematicians use this is because I had to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 words, right? And they could just write 1, 2, 3, 4 symbols, okay? And that's the only reason they do it. Yeah?
Just to let you know, you can't see the whole page.
Oh, can't see the whole page? Sorry. Can you see it now? Okay, so step 1, sum up the individual observations. Step 2, divide the sum found in step 1 by the number of observations. Okay, let's take these little guys. Find the mean. Okay. Thank you, by the way, for telling me you can see that. Yeah.
That answer 2245. I didn't get that. I got 2445.
Okay, let's see what I did wrong.
Or it could be me.
Divided by 244. Oops, I do have 244. Nope, it's just me. It's just me. Yeah, not even the answer key says that, so I don't know what I did. But that's brings up a great point. Okay, you are going to show me on your test your sum and what you divided by. Okay, it's important because if you did what I just did and wrote down the wrong number or had a dyslexic moment and write down 424 or something like that, as long as I can see your sum and your number you're trying to divide by, I know it's just a math error. And I do not count off for math errors. I count off for process errors. Now the reason it's important that you show me your sum and what you divided by is sometimes we're going to divide by something different, not n, it'll be n minus 1 or n minus 2, or it'll be different things in different formulas. And so I need to know what you're trying to do. Maybe when you did your stem plot you left one of these guys out, so you only have 7 observations. So you summed them up and divided by 7. I'll look at your thing and I'll say, oh, you left one out, and I won't count off for it. Because the most important thing to me is that you know the process of how to do this, and then how to interpret the answer, okay? So knowing the process and knowing the interpretation are what matters, okay? And remember, you can use your notes on everything from now on, so you can have the steps there with you to help you, okay? Now, you'll notice a couple of things. Notice that I did subtotals. You'll see me do this a lot in calculations, because if you have a calculator like mine that has a display, it has a character limit, okay? So you can be putting numbers in there and putting numbers in there, and it's not taking them, okay? You can put numbers in there, you can be putting them in there, hit equals, and it will only add the ones that are on the display. You may have had 10 other numbers that you put in there, but it will not add them. So there's a character limit on all of these that have a display. They'll only take so many characters in their memory, okay? So you want to get in the habit of doing small groups of numbers so that you don't run over the character limit, okay? All right? Okay, so like I said, what I do is since I've got my stem plot, I use each part of the stem to do a subtotal, or you could do a running total. Running total would be fine if you did the 109 and then added these two and did the next one, just to keep yourself from overloading that calculator. Plus, if you go back then and subtract backwards, if you did a running total, for instance, and you counted backwards, you subtracted backwards, you could find any mistake that you make. Okay, so it's an easy way to keep yourself from having any kind of common errors like that. But as long as you show me your work, as long as you show me your sum and what you're dividing by, you don't have to write the symbols, but you want to show me the sum and what you're dividing by. If I can see that, if this number's not right, I'll go to the sum. If the sum is not right, I'll go and look at the numbers. Okay? As long as I know that you're trying to add them all up and divide by the number of them, you don't miss a point. Now, if you had 9 numbers here and you divided by 6, then you'd have a problem. Okay? All right? Okay? Or if you just added them up and forgot to divide by it. Okay? Okay? So there'll be situations like if the operation says to square something and you square root it, that's a big mistake. If it says to add something and you divide it, that's a big mistake. So what I care about is that you know which operation to use when, okay? All right? But not the math. Okay, it's not my big deal. Okay, so the mean is a real easy way to find a typical value or a representative value. It's the most commonly quoted one, but it has a lot of problems. Remember our Bill Gates example, right? The mean can be thrown off by these big values, okay? So, in order to test the quality of the mean, to know whether it's reliable or not, you need to use a second value. You always need to ask for 2 measures, okay? The mean is the first one. The second one is the median. Okay. You can use the median to judge the reliability or the trustworthiness or the representativeness of the mean. Okay? So you can use the median to test whether or not you can trust that mean. Okay? Now, what the median, okay? Median, this is not I see a test in your future. That's a medium. Okay. A median. Median. A median. What's the thing in the middle of the road when you're driving down the road? A deer. No. It's the median, right? You know why it's called a median? Because it's in the middle. Median means middle. Okay? All right? So the thing in the middle of the road is the median, and it's always in the middle. It doesn't come over in your lane and over in the other guy's lane, right? It stays in the middle. Okay? So the median is the middle value in a distribution. Half the numbers are above it and half the numbers are below it. It's the physical middle. It may not be a number in the distribution, just like our mean wasn't. You know, we had a mean of 244.5. We didn't have a 244.5. So it may not be an actual number in the data set, but it will be in the middle of the data set. Half the numbers will be above it, half the numbers will be below it. So middle number, middle of data set, half the numbers above, and half below. Now, here's how you find it, okay? Step 1, you find the location of the median. Not the median, but the location where it lives. Okay? You find the location of the median by using n plus 1 divided by 2. So you find the location of the median by using n plus 1 divided by 2. So in this first data set we had, okay, put that up, we had 9 observations, right? So if I take n plus 1 divided by 2, my n was how many? So 9 plus 1 divided by 2, 10 divided by 2 would be
5.
the 5th number, okay? Now, step 2 is I have to put the data in order. Put data in order, low to high, or high to low, it doesn't matter which way, but you just got to have them in order, okay? Now, on these data sets I've given you, I think in your stem plot, I think they are in order. I think I was kind to you. But, okay. So for this first data set, starting at the bottom, I've got 41, 62, 63, 74, 75, 76, strong bones, 87, 88, and 109, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got them all, right? Okay. My median then is going to be the 5th number. 1, 2, 3, 4, 5. Okay, you see that? Half the numbers are below that, and half the numbers are above that. It's the middle number. So the median is 75. So step 3 is count over to the median. Now, here's where it gets fun. So look at the next one. How many observations do you have in the next one? 8. So if we do n plus 1 divided by 2, that's 8 plus 1 divided by 2, right? Which would be 9 divided by 2, which is what? 4.5. We need the 4.5th one. So what we're going to do is we're going to put the data in order. 218, 226, 227, 235, 254, 262, 263, 271. And we're going to count over to the 4th and the 5th. The 4.5. So 1, 2, 3, 4, 5. And we're going to average those two to find the point right between those two. So we're going to take the 4th number and the 5th number. We're going to take 235 plus 254 and divide that by 2. We're going to find the center right between those two. It's 2489 divided by 2, which is 244.5. That's our median. Okay. Now it's not in the data set, but half the data is below 244.5 and half the data is above 244.5. You see, it's right in the middle. Okay? All right, let's do the last, see if you can do the last one. far, so good? Now, you can use the median to test the quality of the mean. In these data sets I've given you, what can you tell about the mean and the median? They're the same in every data set. Okay? Regardless of the problems the data set had, the mean and the median are the same. This one, this first data set, had 2 outliers, but they balanced the data set so that they didn't pull the mean either way, so that the mean and the median are right on top of each other. In this one, both of them are in the middle where we don't have any numbers, right? And down here at the bottom, they're the same. It's a nice balanced observation. If I were to do this calculation and I had a mean of, say, 115 and a median of 90, that would tell me that the mean has been pulled up because the median's in the center. Okay? So this would tell me the mean has been pulled up by a high value. Just like our Bill Gates example. Okay? The median is the thing in the center of the road. The mean is like the car. Right? Okay, it can go in either way. Have you ever ridden in a car that had a low tire on one side and it pulled one way or the other way? Right? The mean is the car, and it can be pulled either direction, pulled one way or the other. The median always stays in the middle. Half the data above it, half the data below it. Okay? So the mean may be pulled way up, or it may be pulled way down, or it may be riding right on top of that median. We hope they're the same. We hope they're right on top of each other, because if the mean and the median are right on top of each other, that means the mean is in the center of the data set, and it's a good representative. But if the mean has been pulled up or the mean has been pulled down, it's been pulled off center. It's not reliable anymore. Okay? Just like our Bill Gates example. If Bill Gates came in the room and his income was really high, he'd pull our average up and it would no longer be representative. The mean would no longer be representative. If you listen to the news gives you the median family income. They don't give you the mean, right? They tell you the median family income in the United States is $43,000. They don't tell you the mean, because the mean could be pulled up by really rich people or pulled down by really poor people, right? So they tell you the median, which tells you what? Half the people make more than that and half the people make less than that, okay? So the median tells you right where the center is, okay? So if somebody comes up to you and says, give me all your money and we'll invest it, and the average rate of return you'll see is 47%. If I told you the mean rate of return is 47%, and you said, well, what's the median? Now, there's a lot of questions you're supposed to ask me, right? What's in? How many years have I been doing this? Is this a parameter or a statistic? Is it all of it or right? All that kind of stuff you're supposed to ask me. But suppose you ask me, what's the median? And I said, the median? Oh, the median is 8%. What does that tell you? I had a couple of really good years, right? And if I've been doing this 30 years, they could have been 30 years ago, right? Right? Okay? If I tell you, oh no, the median, you wanted the median? The median is 48%. What do you think now?
Looks good.
Looks good. Okay? Right? That's what you can do. You can use the median to test the quality of the mean, to know whether or not the mean is reliable or not, trustworthy or not. So if the mean is higher, it's been pulled up. If the mean is lower, it's been pulled down, and it's less reliable. Okay? All right. Now, the third measure of a typical value, so you got the mean, you got the median. The third one that is probably the most useful is the one that is the least known, and that is the mode. Okay? The mode. Now, this is not the thing on the VCR. I'm not very mechanical, and my sister has this big entertainment scene. She's got this great giant television, right? And she's got like all this stuff attached to it and everything, her computer and sound system and all this kind of stuff, and I go down there and want to see the Weather Channel, right? I want to know what the temperature is. So I'm hitting this remote, this gigantic remote, right? And it says, line 1. What is that? line 2. I'm thinking, is this a telephone? What is going on here? What mode is this thing in? It's got PMS or something. And I finally put it down, went outside, which, see what the temperature was, because I'm like, I can't even get the thing to work. Okay, I'm not talking about that. Okay. Mode. Okay. The mode is the most frequent or most common observation. The number that's most frequent. Most frequent. The number that comes up the most. Now, sometimes you won't have one. Sometimes you won't have one because every number will just come up one time. You won't have anything that comes up more than once. But it's the number that comes up more often than anything else. And the reason this one is most useful is because this one has the most applications. For example, if I'm staffing a call center, okay, and I want to know how many operators to have on the call center, I'm not going to use the mean number of calls because that could be pulled up or pulled down, right, by high or low numbers. And I'm not going to use the median because half the time I'd have too few operators and half the time I'd have too many, right? I'm going to use the mode. What's the most common call load? I'm going to look at all my call loads and see what's coming up the most. And that's what I'm going to staff for. If I'm staffing, hospital emergency rooms, how many nurses to have on hand. I'm going to look at the mode, not the mean or the median. Look at the mode. If I'm looking at production levels, I'm not going to look at the average production because that could be pulled up or pulled down. And I'm not going to look at the median production number because half the time we'll do more than that and half the time we'll do less. I'm going to look at the mode. What do we do most of the time? Somebody wants to give you an estimate, right, on the cost of something. Don't give them don't ask for the average cost because the average cost could be pulled up or pulled down, right? Don't ask for the median cost because half the time it'll cost more than that, half the time it'll cost less than that. Ask for the mode. What does this cost most of the time? Most of the time, what does this cost people? That's usually what you ask, right? What does this usually cost? Usually cost. You're asking for the mode, right? Or if somebody gives you an estimated delivery time. Oh boy, we love that one, don't we? Right? Estimated delivery time. You don't want the average. You don't want the median because half the time they'll be late. Okay, half the time they'll be early. You won't be ready. You want the mode. What's most frequent? Okay. So the mode is the one that is the most useful of the three. Even though people don't talk about it very much, it's the one that is the most useful in real life. So 3 ways to find a typical value. Now, there's one more I'm going to show you. Now, these you have to do on your project. On your project, you have to do a stem and leaf plot. Okay. Excuse me, with exploratory analysis. Okay. If I ask you for a stem and leaf plot, excuse me, I'm drying here. I am asking for that analysis. So don't just do the stem and the leaf, do the analysis as well. So you have to do that on your project, and you have to find the mean, median, and the mode. Okay. So you have to do that on your project, and that's what your test will be on next week. Plus, your test will ask you to do the analysis on the stem and leaf plot, and it will ask you to do the comparison between the mean and the median. You ought to get in the habit of always doing that comparison. Always look at the mean and the median and compare the two. If they're right on top of each other, that's fine. If they're separate, if they're different, the mean has been pulled off, okay? But you should get used to doing that. Okay? I'm going to show you one more because this one is a way a number that is really important to some of you is calculated. It is the way your grade point average is calculated. Okay, so if you've ever wondered how do they get that grade point average, here's how they do it. It's called a weighted average. If you do cost estimates, you're doing weighted averages. So, there's a lot of uses, but I don't require you to do one. I don't require you to do one on your project because it's not applicable. But here's what a weighted average does. The first thing you have to do is you have to assign each observation a weight. Okay? And these are not all equal. Are not, that's an R, not equal. So some observations are weighted more heavily than others. Okay? So you assign each observation a weight. Then step 2, you multiply each observation by the weight. Okay? Like I said, if you're doing a cost, if you're trying to estimate the cost of something, like maybe you're going to build a deck or something or put in a flooring or something, you have the price of the tile, like if you're putting in a floor, or price of the carpet, you have the number of hours it will take, you have the amount of glue it will take, you have these prices, and you weight them by how much you're going to use, right? The square foot for the carpet, the amount of time, right? So they each have a weight, okay? And then you multiply each one times that weight, right? Okay, right? And so you assign each observation a weight, you multiply each observation by the weight. Now here's where it's a little different with a weighted average. With a weighted average, then you divide, no, wait a minute, you sum up these answers to step 2. You add them all up to get the total. And usually when you're doing a cost estimate, that's where you stop, okay? You sum these up to get the answer to step 2. But if you wanted to know the price per square foot, right, or something like that, then you divide, but you'd sum it up, okay? Then step 4, you divide the answer to step 2, or answer to step 3, sorry, answer to step 3 by the total weight. The total of the weights. Not the number of observations, but the total of the weights. Okay? Let me show you this with your grade point average, okay? Let us suppose that this term you took 3 classes, okay? 3 classes. And let us suppose, let's see, for grades, we offer A's, B's, C's, D's, and the dreaded F, right? We offer those grades to you, okay? They all cost the same amount of money, okay? All right? And we give them, assign them points. So an A is worth 4, a B is worth 3, a C is worth 2, a D is worth 1, and the F is worth 0, correct? Okay? And it's up to you which one of these you choose, okay? All right? Now let's suppose you took 3 classes and you got 2 A's and a C. Okay? So for each A, you get a 4, and for the C, you get a 2. Now I know there's pluses and minuses, but we're going to keep this simple for me, okay? But not all A's are created equal, okay? These have to be assigned a weight, okay? The A's and the C, that's the observations. We're going to assign it a weight, and we're going to weight it by credit hours. Okay? So let us suppose the first A is in Word Processing CSA 101. How many credits? 1. That's a 1 credit class. The second A is in PED 101 Golf. That's a 1 credit class. The C is in Biology with a Lab. 4. Okay? So, I assign, step 1, I assign each observation a weight. Step 2 is to multiply each observation by the weight. So, 4, 4, and 8. So far, so good? Step 3 means to sum those up. So, 4, 4, and 8 is what? 16. And then step 4 says divide, but divide by what? Not 3, but the total weights. And what's the weights? Credit hours. We call it hours attempted.
6.
Yep. So what's 16 divided by 6? 2.67? Is that right? 2 2/3? 2.67. Now wait a minute. I got 2 A's. How come my GPA is 2.67? I got 2 A's, right? Oh, it's not the grades that count, it's the weighted average, right? It's the power according to the credit hour. Now, here's why we take roll, we call you, we want you to pre-register and register, right? We do all that stuff. Because suppose you committed every student's nightmare, you signed up for a class and forgot. And you ignored all the emails and calls from your advisor, right? And lo and behold, at the end of the term, the teacher was, one of those hard you-know-whats, and gave you the dreaded F, for which you get 0 credit, right? 0 grade points. And let us suppose it was a 3-credit class. Well, your grade points are still 16, but your hours attempted is now 9. Okay, so what's your GPA? Okay, this is why we call you. This is why we're on your case all the time. Get to class. Are you really coming to class? Have you contacted your teacher? What's going on? Now, we do it also because of financial aid. If you get financial aid and you use that to pay the school and you don't show up to class, we have to pay it back. Okay, so we need to know when the last date of attendance, because if you attend past the first, I think it's the first 3 sessions for the 8-week session. So if you go into the 4th week, we don't have to pay it back. But if you don't show up, if you stop showing up the 2nd week, we have to pay it back. So we want to know because of that, and also because it puts you on sometimes financial aid, probation, all that kind of stuff if you just drop. But also because we don't want that to happen to you, and we don't want this to happen to you. Okay? I had a student once. She came in and she was a traditional student down in Crete. And you know how they have the beginning of the year, they have the activity fair where you can sit down in the cafeteria and sign up for every club on campus? Well, she did that. Okay? She signed up for every single club on campus. And so her first term, her GPA was, drum roll please, 0.58. Okay, she'd taken 16 credits and she ended up with a 0.58 GPA. Okay, because one person was kind enough to give her a D. Okay, she graduated in 4 years, but what she did was she worked like a dog the rest of the time because she had to drag that bad term with her for the rest of her career. Okay, so my point is, if you come to me and say, I'm doing really good in my word processing class, but man, that biology class is really hard, I'm going to tell you, spend all of your time okay, on that biology class. It's really important. Okay, what I'm going to hand you now are 2 more examples. Now, these are harder examples. The numbers are harder, okay? And the reason I'm giving you these is because if you can do these, then you can do anything. I have the answers to these, and I'm going to be doing these. If you want to stick around and do these here in class to make sure you can do them, you don't hand these in. These are just practice problems, okay? But I'm going to do them, you can do them, and you can see if you can get it right, get all the stuff right. But once you get the homework, this is not the homework, but once you get the homework, we're done for today. Like I said, we just ease into the math a little bit so people will still love me, okay? And get you primed and ready for the next thing, which is the hardest math. So I'm going to hand out this. Then I have 2 more things to hand out, and then you will be ready to go home. One thing we need to talk about, if you do one of these problems that I handed out to you, students always ask me about rounding, okay? Everybody listen to me for the next 30 seconds because I'll have to say this every time we meet because people don't hear me, okay? Always round to 1 decimal place beyond what I have given you. So if I've given you whole numbers, round to the 1st decimal place, okay? If I give you 2 decimal places, round to the 3rd, okay? If I give you 4, go to the 5th. If I give you, right, okay? So always go to 1 decimal place more than what I've given you. And the way you round is if it's, 5.67, and you're rounding to one decimal place, that would be 5.7, right? You go up. If it's 5.42, you go 5.4. You go down. So if it's below 5, you go down. 5 and above, you go up. Okay? I know sometimes in medical fields they just round everything up, but we're going to do that way. Okay? Now, I don't count off for rounding if you show me all your work. Okay? So don't get all. And that's the one thing that in the whole class, the thing that people get most uptight about is rounding. Okay? All the math we do. Okay? Also, of the stuff we've done today, what do you think is the most missed concept of everything we've done today? The stem plot, the leaf, the exploratory analysis, the mean median mode. What do you think is the most missed concept? No. No. The median. Because people will do n plus 1 divided by 2 and say that's the median. That's where the median lives, right? You have to put it in order, or they'll forget to put the data in order. So study the median. If you don't think, oh, that's easy, I don't need to study that, study it. Okay? Listen to the voice of experience, which is me. Okay, here comes the homework. It is front and back. Okay? Make sure you do it. Once you get the homework, if you want to leave, you may. Otherwise, I'm going to stick around and work these problems for anybody that wants to work. Go have a baby. Or go see if a baby's been had. I'm just going to work on these examples, okay? Here's two for you guys.